Okay, so our basic efficiency equation, efficiency is output divided by input. So this could, if you're referring to, a furnace at your home, or a giant natural gas boiler in a school, or something as large as a power plant. If you want to know the efficiency of the power plant, you need to determine the total output over the total input. And this kind of makes fundamental sense. If something's 100% efficient, that means you get all of the output, or the output is equal to the input, right? So that's your 100% efficiency. If it's 50% efficient, that means you get half the output for the total input. Okay. So what's nice about this is you can rearrange this. You can rearrange this equation. If you have any of these two quantities, you can figure out the third. So let's figure out what output here is. If you want to take a second and see if you can figure out what the equation for output would be, go ahead. Okay. So if you basically what you have to do is multiply both sides by input. Okay. So input times this side and input times this side. Input's going to cancel out on the left side, and then you're left with input times efficiency equals output. Okay, so if I know the input and the efficiency, I can determine the output. So go ahead and take a second if you want to determine the equation for input. Okay, so in this case, we're going to divide both sides by efficiency. If we divide by efficiency here, efficiency cancels out, and then we have the input is output divided by efficiency. Okay, so these are three really, really important equations in the world of energy. I have trouble remembering these, to be perfectly honest, so what I've found to be a very helpful mnemonic is this, what I call the efficiency triangle. And so this is your output, input, and efficiency. So if I want to know input, it's output divided by efficiency. Efficiency is output divided by input. And then output is input times efficiency. Okay, so that's your basic. And I go over this in an example, a sample calculation, which you can click on now to view that calculation. Okay, so here's your basic efficiency equations. So let's look at power plant output. Okay, this is really important. This is something that was in your reading. But when you look at, if you want to figure out how much electricity a power plant is generating, okay, you have to look beyond simply the capacity, and I'll go over this in a second here. So basically, first of all, what does capacity mean? Okay, does this mean this is how much this power plant is churning out constantly? Well, the capacity, as it turns out, is your maximum power output. So this, when you have, for example, here, this is a nuclear generating facility in New Jersey, just across the Delaware River from Delaware, where I am right now. And it says it's rated at 2,357 megawatts. So what does that mean? That means under ideal conditions, they're going to be churning out exactly this much power. Remember, megawatt, watt is power. Megawatts power, kilowatts power, gigawatts power, right? So if you do a quick conversion here, think about this. How many gigawatts is this? So go ahead and think about that. Okay, so there are 1,000 megawatts in 1 gigawatt. So this is a 2.35 or 2.36 gigawatt generating facility. Okay, so that tells you the maximum amount of power it's going to put out. So that's its peak power. Okay, now if I want to determine how much it's going to put out in a year, I'll go over that in a second. But if you want to know how much energy or power is required to generate that output, you need to know the efficiency of the plant, and we'll go over that in a minute. Okay, so remember, this is the output. This is not the amount that's going in, and it's not always the amount that's going out. This is its peak generating capacity. Okay. Another consideration here, if you want to look at the total generation over a period of time, you need something called the capacity factor. And this was also in your reading. So the capacity factor tells you your actual output over the maximum possible output over a period of time. So you can see it's kind of like, it's similar to efficiency, except you're taking output over output. So in other words, if you take, this generating capacity over the course of a year, but because of downtime with fixing up the facility, or maybe something goes wrong or whatever, it's not going to be putting out 100% of that power every hour of the day all year long. So if you could figure out how much it's actually putting out divided by the maximum possible output, that tells you your capacity factor. This is really important for both non-renewable energy and for renewable energy, and we'll go over that with some other renewable energy sources. Okay, so this basically tells you what percentage of the maximum possible output you're getting out of a generating source. Okay, so some questions I'll answer in a video are the following. These are questions when you think about electricity generation. So we'll start with the basics, and I'll go over if this plant is operating at peak capacity, how many kilowatt hours a day would it generate, and how many kilowatt hours per year. This is a very basic, important consideration. The average transmission and distribution losses, this was gone over in a previous presentation, in the U.S. Are 8%. So from the time that the electricity is generated at the power plant to when it gets to the end user, like a house or a business or whatever, you lose in the U.S. about 8% along the way. So if that's the case, how many kilowatt hours actually get delivered to the end user? Now we're getting into some of the more practical considerations. If you have a 90% capacity factor, how many kilowatt hours a year would it generate? Okay, so we're going to look at the maximum generation capacity, and then we'll look at the sort of more realistic generating capacity. 90% capacity factor is pretty realistic. And then finally, assuming a 33% efficiency, which is about the average efficiency for power plants in the United States, how many kilowatt hours of energy are input into this power plant each year? Okay, so I'll answer these questions in another video.